So this lesson's all about adding polynomials symbolically. So the first question is 5t take away 3 plus t take away 9. So what we're going to do is we're going to identify our like terms. So 5t is a like term with positive t. Negative 3 is a like term with negative 9. The very first thing that we're going to do is we are going to group our like terms. So 5t plus t, take away 3, take away 9. Remembering to take the signs that are in front of the terms. Did I give you a lesson, Ethan? So, what's 5t plus t? So you have 6t. Negative 3 minus 9 is what? Beautiful. So the answer is 6t take away 12. Good enough. That's the first question. Okay, next question. We are going to hunt for our like terms. So, I have a 4D here. Is there any of these terms that are like terms with 4D? No. It's a loner. Okay. I've got 3DF. Is there any terms here that's a like term with 3DF?
Yep.
What? DF, correct. So 3DF is a like term with DF. And the last two terms that we haven't chatted about yet are negative F and 6F. Are those like terms?
Yeah.
You betcha. Negative F and 6F are like terms. So altogether, there's 5 terms between the two polynomials, and we have 2 pairs of like terms, and we have 1 term that's all by its lonesome. Okay? So our next step is grouping our like terms. So I'm just going to write the 4D by itself. It's along for the ride. Nothing's happening with that 4D. Then we could put the 3DF together with the DF. And last but not least, we'll put the negative F with the 6F. And then it's just a matter of figuring out the answers or combining our like terms. So 4D, nothing changes there because there was nothing to simplify it with. If you put the DFs together, how many DFs do you got?
4 DF.
How many?
4.
Beautiful. 4DF. And if you put the F's together, how many do you got?
5F.
Excellent. Plus 5F. And that's it. That's how we do that question. All right. Here we got 2 examples, and then we have like a kind of like a, not a word problem, but like a problem. So here we go. We'll start with the first one. Where are like terms at? So we got 3b squared. What is the like term with 3b squared? Great. Then we have negative b. Where's the like term with negative b?
5B.
5b. Last but not least, we have negative 12. Where is a like term for negative 12?
Negative 13.
Excellent. So once we have that in mind, then it's easier for us to group these so that we can simplify them. So we've got 3b squared and 11b squared. If we group the b squareds together. After grouping the b squareds together, we'll group the b's together. So that's negative b plus 5b. And then we'll group our constant terms or our numbers together. We've got negative 12, take away 13. And then it's just a matter of remembering our rules for integers. How many b squares are we going to have all together?
14.
Beautiful. 14 b squareds. How many b's will we have?
4.
We'll have 4b. And whenever we say 4, 4 is the same as positive 4. We don't have to say positive 4. We can just say 4. 4 means the same as positive 4. And what do we have when we put our two numbers together?
Negative 25.
Indeed we do. We've got negative 25. And that's what we get as our fully simplified answer. Great. So here we've got 3 polynomials. Let's start off with 5m. Where's a like term for 5m?
2m.
2m. Okay, there's a like term. Okay. Then we've got negative mn. Where's a like term for negative mn? 4mn and positive mn. So 3 of those are like terms. We only have 2 terms left. 3n and minus n, are those like terms?
Yeah.
You betcha. So positive 3n and minus n. And now it's just a matter of writing them all together. So 5m plus 2m minus mn plus 4mn plus mn plus 3n minus n. So that's how we group all those terms together so that you have the m's together, the mn's together, and the n's together. How many m's do we have?
7.
We got 7 m's. How many mn's do we have?
4.
4. Negative 1 plus 4 is 3. Plus 1 is 4. And how many n's do we have?
2n.
2n. 3 minus 1 is 2. So we end up with an answer of 7m plus 4mn plus 2n. And that leaves us with one last example to do. What's the perimeter of the triangle shown below? So we're going to talk about perimeter, area, surface area, and volume, I believe, is our first unit when we're back together in February. Now, perimeter is something that you probably should have seen before grade 9, but, you know, COVID and everything, who knows if you have. Does anybody know what perimeter is? It's the distance around an object. So, in other words, you take this, you take this, and what do you do with them? You add them. Now, when you did perimeter before, you would have had nice numbers like 7 or 12 or 19.2. But now, we're talking about polynomials. So we are going to add, the first one is 2n plus 7. The second one is 3n plus 2. And the last one is 4n plus 4. So we are going to add those three binomials together to figure out the perimeter. Now, before we do that, let's think about what the like terms are. So let's talk about 2n. Where are the like terms for 2n? 3n and 4n. Where's the like terms for 7? 2 and 4. So in this question, there's only two types of terms. Terms with n and terms that are numbers by themselves. So if we put this all together, we have 2n plus 3n plus 4n plus 7 plus 2 plus 4. What does that give us? 9n plus 13. There you go. That is the perimeter of the triangle.